Assalamu alaikum, dear students. Dear students, in our today's class, we'll be discussing one of the most important topics in terms of board exams, that is imperfections or defects in solids. So, as far as the crystalline solids are concerned, the arrangement of constituent particles in crystalline solids is ordered and ideal. But this ordered or ideal arrangement of constituent particles throughout the crystal is possible only at or somewhere around absolute zero temperature. So if the temperature is higher than absolute zero, which usually is actually, the arrangement of the constituent particles is somewhat disturbed. Due to this disturbance in the ordered arrangement of constituent particles, this gives some, rather, this generates some disorder inside the crystalline solid. And this disorder within the crystal of a crystalline solid is called as imperfection or defect in a solid. So we can define imperfection or defect in a solid as the disturbance or the deviation from perfectly ordered arrangement of constituent particles in a crystalline solid is called imperfection or defect in the solid. These imperfections or defects in case of crystalline solids are having tremendous influence on properties of crystalline solids. That's why at times the defects are introduced deliberately in these crystalline solids so as to have tuned properties which can be of tremendous technological uses. Now let us see what are the different types of imperfections or defects in crystalline solids. The two broad classes of defects in case of crystalline solids are: number one is point defects and number two is line defect. We'll be taking first point defects. So as the name suggests, a point defect is that type of defect in which the disturbance in the arrangement of constituent particles is around a particular constituent particle or around a particular lattice site. Such a type of imperfection or defect in which the disorder is somewhere around a particular atom or a particular lattice site is called as point defect. Simply, you can define point defect that type of defect in which the disturbance in the arrangement is around a particular atom or constituent particle in general or around a particular lattice point. Point defects are further divided into or classified into three subclasses. Number one is stoichiometric defect. Stoichiometric defect is that type of point defect in which the stoichiometry of the crystal is not disturbed. That is, if we talk of ionic solids, the relative ratio of cation to anion is not disturbed due to defect. If the defect does not disturb, does not change the relative proportion, the relative ratio of cations and anions of the ionic solid, then such a type of defect will be called a stoichiometric point defect. For example, if you are having a solid, ionic solid AB, having A cations and B anions. So if equal number of cations and anions are missing from their lattice sites in the crystal, the relative ratio of cation and anion won't be disturbed. And such a type of defect will be called a stoichiometric point defect. Number second type of point defect is non-stoichiometric defect. Non-stoichiometric defects are those point defects in which the stoichiometry of the crystal changes as a result of defect. That is, the relative ratio of cation to anion is disturbed. If in the ideal crystal, that is a crystal without defect, the relative proportion is 1:1. When the defect is introduced, the 1:1 ratio will change. It may become 1:0.9 or whatever. Another type of point defect is impurity defect. So, impurity defect, as the name suggests, is that type of point defect in which a foreign body or a foreign particle occupies an interstitial site or a lattice site in a particular crystalline solid. And such type of defect, which results as a result of some impurity, some foreign body, it is called as impurity defect. Now we'll be taking types of stoichiometric defects.